These four gears will be having a teeth axis and the axis of shaft both are parallel. And these four gears will be used where the two shafts are the power to be transmitted between the two shafts, those are parallel to each other. And these gears make a lot of sound, so that these are not preferred for heavy transmission at high speed. Okay, only for the rough work, just like in gelling machine and all, crushers and all, we can use this. And these are called first generation gears because the tooth profile will be very simple. And the next one, the helical gear, the helix angle, the angle of made by the tooth axis on the axis of the shaft will be some angle beta. Okay, and due to this particular design of this teeth, what happens? There will be gradual engaging of teeth. The driver and driven will be engaging gradually. So due to this, what happens? There will be uniform torque will be transmitted. One thing, and at a heavy speed, the gears will not make the sound. So that these are preferred to transfer the power between the two parallel or non-parallel shafts when I require to transmit the maximum speed at high speed at maximum torque without speed, much more sound. Okay, even at elevated speed, they will not make the sound, so that they can be used for heavy torque transmission at very high speeds. Okay, one thing. And the bevel gears will be used where you can please remember, bevel gears will be used when the axis of the shaft are 90 degree, more than 90 degree, lesser than 90. The two shafts, the power to be transmitted between them will be making an angle. There we are going to use the bevel gears. The bevel gears are cut down on a conical surface or conical drum. Okay. The next I had told you about the application of the bevel gears. Where first one is differential gearbox. The second one to operate the shutters, the closing and opening the shutters. You can write. The next one I come to the worm and worm wheel. Here the worm is fixed on the always driver, and the worm wheel will be fixed on the driven gear. Correct now? And these will be used for a transmission of power, and at the same time it will be preferred for the self-locking because these teeth will be making a self-locking among themselves. Correct now? And this worm will be made out of a harder material and worm will be made out of a smoother material like brass, bronze, copper and the aluminum of the smoother materials. Those will be used. Okay. And due to high temperature or heavy friction, what happens? The heat will be generated so that this will be immersed into a gearbox. You can see that in the most of the gearboxes and all, it will be having the oil. In the oil bath, it will be mixed. So that, okay. And the application, you can see a screw job and the operation of your shutters and all in automation. And if you cannot remember, please remember you write automation. If you cannot remember that, if you get confusion, you write automation. Okay, automation, differential gearbox, automation, all this you can write, no problem. And the rack and pinion, whenever you are going to transfer the power, that means whenever you want to convert the linear motion into rotary motion or rotary into linear, that time we prefer to have the rack and pinion systems. Correct, no? And it will be used for the automation purpose. And some of the, you can see in gates also, main gates, it will be used for the movement. That also can be written if you want. Okay. And one example I had given, if you can able to remember, please remember that it is operation of the drill bit and operation of the table. It can be moved up and down by using the rack and pinion mills. Okay. Now let me come to the velocity. I was talking about the principal drives. Whenever the two gears are meeting each other, or two gears we are going to use to transfer the power, one has to identify which is the driver gear and which is the driven gear. Already I told you very simple way to find out the gear which is fixed on the source of power shaft. That will be always called as the input gear or driver gear. The gear which will be following it is called as a follower or driven gear. Follower or driven gears. Okay, for example, you say now you can write like this. First one, please write simple, smaller one. The next one, you write slightly bigger one. And see that this gap should be same. Because the axis we say, this gap should be same. You can see it. And if you want to write, you can even write like this also. Okay. Okay. So this is called driver gear. And this is called driven gear. Okay. And let's say P1 is the diameter of the driver gear, N1 is the speed of the driver gear, and T1 is the number of teeth of the driver. And this T2 is the diameter of the driven gear, and N2 is the speed of the driven gear, and the T2 is number of teeth of the driven gear. Number of teeth of the driven gear. Define velocity ratio. What is velocity? Velocity ratio is output speed to the input speed is the velocity ratio. That means in other way, I can say N2 by N1. N2 by N1. The angular velocity of the driven gear to the angular velocity of the driver gear. This ratio is called as the velocity ratio. Correct? And now to show that if it is for 5 marks, what we can write? We can write the figure. This figure I have written. Let us say these are the two gears 1 and 2. These are the two gears 1 and 2. Say T1, N1 and T1 are the diameter, speed in RPM and number of teeth on the driver gear. And say T2, N2, T2 are the diameter and the speed in RPM and the number of teeth on the driven gear. Then the velocity ratio, the ratio of the speed to the driven gear to the speed to the driver gear is called as velocity ratio. This is represented